All right, we have another lesson on graphing. Today it's going to be about logarithmic functions. So for the lesson today, you will need your note packet, and then you also need a graphing calculator. If you have not clicked the link on the Google Calendar how to download one of these, please do so because you need to be able to use the log base function, which is in your menu. If you have a TI-83 graphing calculator, you will still also need to download this one in order to actually get this to work out. Okay, so today, like I said, we are talking about logarithmic functions. So logarithmic functions are actually the inverse to the exponential functions that we graphed the other day. So your parent function for this one is f of x is equal to log of x. So once again, there's no base on this one, but you assume it's base 10. Okay, so the graphs that we talked about the other day, we had an asymptote at 0, we crossed at 0, 1, and then my graph went like this, give or take. Okay, so those are a majority of the graphs that we did last week. This week, we're going to talk about graphing logs. Difference is my asymptote is vertical, and we cross at 1, 0, so my graph will look like this. Okay, if I were to turn this graph this way, it looks like my log function. Okay, so you can actually ignore this since we all have a graphing calculator that works. So we're going to make life a little bit easier for us. Okay, so the first thing that we need to do is you need to figure out where your asymptote is going to be. Since they're vertical, that means the asymptote is always going to be x equals. And for your asymptote, you're looking for parentheses. So let's say I put this in a parenthesis. There's no number added or subtracted inside that parenthesis, so x would be equal to 0. That will be the same every time we do these. You are looking for the parentheses. Okay, so we will create an XY chart just like we did last time. And the easiest thing to do is just plug this into our calculator, and then we'll find our whole numbers in order to graph them if there are whole numbers. Okay, so we're going to go to y equals. To get your log base, you have to hit alpha window, and then you want number 5, log base. So we have log base 2, arrow to the right, and then we want x. Okay, and then if there's anything outside the parenthesis, make sure you arrow outside of it. To get your table of values, you're going to hit second graph, okay? And we want to start graphing all of our whole numbers as possible. Okay, so if you notice, it says that there's an error at 0, which makes sense because we said that's where the asymptote is. So I'm going to use all numbers. I'll use 1, 0. I'll use 2, 1, 4, 2. Let's just see if there's any other whole numbers so we can get a better picture. Oh, and then we also have 8, 3. So this is what should be written down on your paper. Let's go through and graph these. Okay, so my vertical asymptote's at 0, kind of hard to see. We have points at 1, 0, 2, 1, 4, 2, and then 8, 3. And you're going to connect your dots, and then you're going to have it go close. Pretend I actually hit all those dots because I can't read it. And then you're going to go close to the asymptote, but you won't touch it. Now, last week, all of our graphs had a domain that was all real numbers. But if we look at this picture, the first left that my graph goes is at the asymptote, which is 0, and then it goes to the right forever, which means it's going to positive infinity. Once again, your 0 is in a parenthesis and not a bracket because it goes to the asymptote, and the asymptote means I can never actually get to that number. Your range, on the other hand, is the one that will be the same through all of them. I have an arrow that's pointing down and technically an arrow that's pointing up. So range is going to go from negative infinity to positive infinity. Okay, so your end behavior is probably going to be the hardest part of this because you're actually looking for your x values and not your y values. So the first thing that we need to do is we need to figure out between these two arrows which of the y values are going to positive infinity. Well, my y values are going to positive infinity when they're going up, so that means we're talking about this arrow here. And where is that pointing to in terms of my x values? Well, it's pointing to the right forever, which means my x values are going to positive infinity. Okay, so then we have to figure out my left arrow. Sorry, I was trying to get another color. Okay, so we're trying to figure out where x or my y values are going to negative infinity, and they're going to negative infinity right here. But my x value that it's approaching is the asymptote, which is 0. So if you notice, like last week, my end behavior will always have an infinity sign, and then it will also include the asymptote, except we're trying to figure out the x values and not the y values. A little bit more complicated. Last but not least, we're trying to find the x-intercept. Your x-intercept is when y equals 0. And in this case, it occurs at 1, 0. Okay, let's try one more like that before we move on to some of the more complex ones. So let's go to our graphing calculators. Go to y equals. I think it's just easier to clear everything out that's in there. You're going to hit alpha window, go down to number 5 because we want the log base. We want 1/3, so I just do 1 divided by 3 to make life a little bit easier, and then of x. Once you have it typed in, we're going to go to second graph and look at our table of values. Once again, we're going to try and find all the numbers. You should be able to find about 3 to 4 points on these, and if you have to use a decimal, please use a decimal, but you should be able to get at least 3. Okay, so we're going to have points at 1, 0, 3, -1, and then 9, -2 are the easiest ones to graph. So if we go back to our paper, we should be able to find the asymptote. There's no parentheses, but if there's no parentheses, that means I'm adding or subtracting anything. So it means my asymptote's at 0. So let's go through. Once again, it needs to say x equals because it's a line. If you just write 0, then you're telling me it's a number when it's a line. So please include the x equals. Okay, so let's graph our points. We have 1 at 1, 0, 3, -1, and then 9, -2. And connect our dots. Okay, that's a little bit better this time. Okay, domain, we're talking about x values. The furthest left that I go is x is equal to 0. And then my graph is to the right forever, which is going to positive infinity. Your range, I have an arrow pointing up and down, which means we will go on forever. So it'll be from negative infinity to positive infinity. Last but not least, we are trying to figure out where y values are to figure out the x values. When y goes to positive infinity, you're looking at the arrow that's pointing up, which in this case is my left arrow, but my x value is approaching the asymptote, which is at 0. My y values are going to negative infinity over here, and my x values, though, are going to the right forever, which means they're going to positive infinity. Now, I understand that they're below the x-axis, but that's because my y values are negative. My x values are still going right forever, which means I'm going to go to all the positive x values. Once again, my x-intercept is where y is equal to 0, which is at 1, 0. Okay, let's try a couple more and see how we do. Okay, if you look at number 3, this is when you're going to start seeing some of the different shifting on these. Okay, so what we need to figure out first is the asymptote. We actually have a parenthesis right here. That parenthesis tells me my asymptote is at the opposite. So if that's a -1, this becomes a +1. So it's always the opposite, just like any set of parentheses we have in the past. All right, let's draw our x by chart. Let's go back to calculator. Hit y equals. I just, once again, clear everything out so I don't type anything wrong. We hit alpha window number 5. We're going to have 4. And then we will do x minus 1. Once again, arrow outside of it. There's nothing else. So now we will hit second graph. Okay, and then I find whole numbers. We have 2, 0. You can easily plot 0 and 0.5. I would do 5, 1. And 9, 1.5 is also easy to graph. So those are the points that I'm going to include in my table of values. Okay, so when we're at 1, that means I have a vertical asymptote right here. My first point is at 2, 0, 3.5, 2, 3, 4, 5, 1, and then 9, 1.5. And here's my graph. My domain, the furthest left that I go is the asymptote, which occurs at 1. So that means my domain is going to start at 1, but it goes to the right forever, which goes to positive infinity. My range will always be the same. I have an arrow that's pointing down up forever, which means we will go from negative infinity to positive infinity. Okay, so for my arrows, we're trying to figure out where my x or my y values are going to positive infinity. Well, my y values are going to positive infinity for this arrow because it's going up. It's pointing to the right forever, which means my x values are going to positive infinity. I want to know where y is going to negative infinity, which would be this arrow over here. It's pointing to straight down. but the x value that's approaching is the asymptote, which occurs at 1. Last but not least, you're trying to find your x-intercepts. You're looking for when y is equal to 0, and that happens at 2, 0. Okay, I'm going to try and get through 2 more if I can, and then you can try some on your own. Okay, so number 4, do you have parentheses around the x minus 2, or are there no parentheses? So if you look up here, these ones automatically had parentheses, correct? So that means the minus 1 was inside of it. Since number 4 doesn't have parentheses, that means the parentheses are technically only around the x, and then your minus 2 would stay outside of it. Okay, so don't just magically put parentheses around the x and the 2 because they're not there to begin with. So since there are no parentheses, that means the asymptote has to be at 0. So I want to talk about how to plug this in because this is where a lot of you will make an error, and it's pretty easy. But when we go to plug it in, you go to y equals, once again, clear it out. We're going to go to alpha window, number 5. When we go to type this in, we're going to do 3, arrow to the right. Now your calculator will automatically put parentheses. So we only have the x inside that parenthesis. It's very important that you arrow outside of that parenthesis and then do your minus 2 because your minus 2 was not inside the parenthesis to begin with. So please be very careful when typing this in. So now that you have it typed in, you can hit second graph, find your table of values. I'll use 1, -2, 3, -1, and then 9, 0. And let's get the rest of this graph. Okay, so x equal to 0, here's my vertical asymptote. I have a point at 1, -2, 3, -1, and then 9, 0. Domain, the furthest left that I go is when x is 0. It goes to the right forever, so it goes to positive infinity. My range is always from negative infinity to positive infinity. Okay, so I need to figure out where my x or my y values are going to positive numbers. So my y values are going to positive numbers over here, which means my arrow's to the right forever, and my x values are approaching positive infinity. My y values are going to negative infinity on the left side, and that left arrow is pointing down, but I need to know the x value, which is 0. It's approaching 0. And then my x-intercept is where y is equal to 0, so that occurs at 9, 0. Okay, we have time and more, so let's do number 5. Let's go through and plug this into our calculator. We will go to y equals, clear it out. We're going to type in alpha window, number 5. We'll do 1 divided by 2, and then we have x plus 9, arrow outside of that, and then we'll do our plus 4. Go to our table of values. I'm going to scroll up a little bit because you can go between -10 and +10 to get your table of values. The reason you can do that is because those are the only values that you have on your graph. So I'll use the points -8, 4, -7, 3, -5, 2, -1, 1. Let's see, we have lots of numbers to choose from, which is really nice on this one. And then I'm also going to include 7, 0. Okay, so for this one, whoops, wrong button. My asymptote is from inside the parenthesis, and we do the opposite. So if that's a positive 9, this is going to be at a -9. Okay, let's graph our points. We have -8, 4, -7, 3, 5, 2, -1, 7, 0. Okay, so this one is super elongated, but that's okay. Domain, the furthest left that I go is -9, and I go to the right forever, it's going to positive infinity. My range is always negative infinity to positive infinity. I had to figure out where my y values are going to positive infinity, which would be over here. The arrow is pointing up, but my x values are approaching the asymptote, which is at -9. I need to know where my y values are going more negative, and they're going down over here, but my x values are going to the right forever, which means we are approaching positive infinity. Last but not least, we are trying to find the x-intercept, and that's when y equals 0, and that happens at 7, 0. The end behavior is going to be the hardest part, so please try your best to figure that out. If you have any questions, please let me know. If not, have a good rest of your day.